So let's take a minute and talk about image quality in relation to ribeye images. So ribeye images are the hardest image for most field technicians to collect. It's very difficult to find the angle of the 12th and the 13th ribs and get the probe placed in the proper location. We're going to say this green bar represents where the probe should be placed. Now over here we've got a ribeye image with the landmarks drawn in. The landmarks are the guide to the field technician to tell the field technician while they're scanning if the image is collected in the right location. And then it's also what the lab technician looks at before they decide whether or not they can interpret the image or process it. So let's just go through and talk about intercostals. That's probably one of the biggest areas of problems with collecting proper ribeye area images. So this image is an example of an acceptable image. It has all of the landmarks present. It's fairly easy to find the outline of the ribeye area, and we can feel comfortable with the data. The intercostals in this case are parallel. You can see the top intercostal and the bottom intercostal, and they run parallel. And the shape of the ribeye is the shape that we would expect it to be. Now, when we move to an image that is marginal, image quality score marginal, because the intercostals are running together, because the shape is not what it's supposed to be, we have this weird V in the image, then this image would be what I would consider a textbook marginal image. Marginal images get processed, but they should get cross-checked by a second lab technician. The intercostals, top intercostal runs together, bottom intercostal, they're running together right in here. We've got this V, and then we have this finger-like thing pushing up, and that's just kind of the edge of the rib wanting to push up. And if we look over here, we can see the red bar represents where the image was probably taken. And all we're trying to show here is it's a little too straight. The field technician wasn't parallel to the 12th and 13th ribs. They were a little too straight and therefore got close to a rib. Now in this case, the field technician is flat out across the rib. And this finger-like projection with a single line here is a rib. The intercostals are running together and we no longer have that shadowy thing. We still have the V, but this is a solid line, and this represents the image being collected across a rib. Now the problem with this is, any of you that have done meats judging and been in the cooler will know that the ribeye area over the ribs is going to be smaller than in between the ribs. So if we treat every animal the same and we expect the image to be collected between the ribs, then processing an image like this would grossly underestimate the ribeye area. So that's why it's rejected. It's because it's collected too straight across the rib. Now another issue that kind of comes up would be contact, and here's an example of an acceptable image. Really no problem with contact. The landmarks look good, we can process it. This image I would call marginal for contact. The lateral end is dark. So it would be very difficult to interpret. I think we can make out the break of the intercostals and process it, but it's questionable. The data that we get, is it perfect? Well, it's not perfect, but can we do it? And I would imagine most lab technicians are calling an image such as this marginal in providing a data point. Now this is an example of a contact that I would reject. The lateral end is very dark. We can't see the break in the intercostals and know for sure how far out the lateral end goes. So this would be a case where there would be no data reported back on this image, and that's why. It's too dark, and to process it would be total guesswork on this end of the image. Let's talk about the medial end. So this is a medial end. Again, this is an acceptable image, looks good, easy to interpret, no problems. Here's an example of a marginal medial end. I call it marginal because I can see some tick marks and make out the medial end of the ribeye. and feel fairly comfortable with how I would interpret it, but there is some guesswork going on, so it would need to be marked marginal and have a second set of eyes look at it. Now, another problem with medial end can occur with probe placement. So in this case, the red bar shows where this image was collected, and it's collected too low. So the field technician saw this acorn fat, assumed it was medial end, put it on the edge of the screen, and in fact, if they just air traced it, they would have seen that they were off the screen. But what happened? This image is collected too low. So much of the medial end is missing, this image would be considered rejected, and no ribeye data point would be presented on this animal. So let's talk about lateral end. So again, we've got a good image, all the landmarks are there, easy to interpret, acceptable. Here's an example of a marginal image that I would call marginal, and it's because of this lateral end. Now this is a higher marbling animal that has, and the higher marbling animals tend to have less definition on the outside of the ribeye area, but I don't have much question where I would draw this image until I get over in here. And then the lateral end is right on the edge of the screen. You can see what I believe to be the break in the intercostals and the lateral end on the edge of the screen, but it's kind of iffy. So this is an example of an image that would get interpreted and then should be cross-checked by a second set of eyes. In this case, the field technician collected the image, the probe was placed too high. In the lateral end, which is down here, medial lateral, the lateral end is completely off the screen. So we can't see the break in the intercostals. It could be out here, the lateral end could be out here, but it would be total guesswork to process this image. So we reject it and don't report a data point. So hopefully that kind of gives you just some real basics on image quality, and that probe placement plays a role in what the image looks like and then what we can do with the image and whether we can process it.